morning, students. I welcome you all for another session. So, yesterday we have seen that different limit states to be considered in the design of elements. Okay, that is a limit state of collapse and limit state of serviceability. Now, another important factor to be considered in the design of structures or structural elements is characteristic strength of materials and characteristic loads that will going to be considered. First, note down this is the important factor you should remember. So that is characteristic strength of materials. So what do you mean by this characteristic strength? So as you know, the different materials we are using in the RCC, that is two important materials. One is concrete and another one will be steel. So we should know what is the characteristic strength of concrete and characteristic strength of steel. Before that, what do you mean by characteristic strength? That will going to be see. Here, the characteristic strength of a material is that value of the strength of material below which not more than 5% of the test results are expected to lie. Okay, so what do you mean by characteristic strength? Characteristic strength is nothing but a strength below which not more than 5% of the test results are expected to lie. For example, if you take I want to know what is the characteristic strength of concrete. Okay, so there are different grades here. Different grades of concrete we will be using in the design, like M5, M7.5, M15, M20, M25 grade, M30, M35 grade, M40, like that, so on. It continues. Okay, so these are the different grades of concrete. I am talking about the concrete, not cement. Okay, so these are different grades of concrete. Then what do you mean by this M15 or M20, M25, M30, M35, like that? So the first letter, that is M. M indicates mix. Okay, M indicates mix. Then the number, that is 15 or 20, 25. So these indicates what? The characteristic strength of concrete, that is compressive strength. I am talking about the compressive strength. Characteristic compressive strength of concrete after 28 days of curing. Okay, when you prepare a concrete cube, okay, so using any grade M15, M20 or M35, okay, so prepare the concrete cube. Okay, so after preparing, keep it for 28 days of curing. Keep it in water for 28 days. After 28 days, you remove the cube, okay, and test it. Apply the load, compressive load, and test it, and whatever the strength we will going to get. Okay, so based on that strength, it will be numbered. That is, M15 means characteristic strength of concrete. Okay, after 28 days of curing, the strength should not be less than 15 Newton per mm square. If I say M15 means the strength of that concrete, compressive strength of that concrete should not be less than 15. So if it is more than 15, then we are going to grade that it is M15 concrete. So M indicates mix and 15 indicates characteristic compressive strength of concrete cubes after 28 days of curing. So curing period is fixed, that is 28 days. After 28 days, whatever the compressive strength we are going to get, that will be designated as like this. So these are the different grades of concrete. Now remember, so for plain concrete, right, without reinforcement, if you want to use the concrete, plain concrete, we can use M5 grade, M7.5 grade, M10 grade, M15 grade. So up to M15 grade concrete we can use for plain concrete, PCC, we can say that. When you want to design RCC elements, like if you want to place the reinforcement, then for RCC minimum grade is M20. From this onwards we can use for the RCC, right, concrete grades. but below this, okay, we cannot use M15 for RCC elements. Okay, so up to M15 we can use the grade of concrete for plain PCC elements. But if you want to go for the RCC, the minimum grade required is M20. So I can use M20 grade concrete or still higher grade of concrete. So remember, M indicates mix and number indicates characteristic compressive strength of concrete after 28 days of curing. Okay, so based on that, these numbers will be. Okay, now what is the characteristic strength? The characteristic strength of the material is the strength below which not more than 5% of the test results are expected to lie. So what do you mean by this? Suppose if I prepared 100 cubes, normally concrete cubes will be of size 150 mm by 150 mm by 150 mm, that is cube. So if I prepared 100 cubes like this, then after 28 days of curing, if I test the compressive strength by applying the compressive load, then 95% of the, okay, 95% or 95 numbers, 95 cubes will going to give strength more than what is designated. If I want to know what is the characteristic strength of concrete after 28 days of curing, so how we have got this 15 number or 20, 25, how we have got this? So I will going to prepare 100 cubes, okay, concrete cubes, and after 28 days of curing, I will going to test all the 100 cubes, and out of 100 cubes, 95%, 95 numbers, 95 cubes will going to give the strength more than 15. Okay, only 5 cubes will going to give less than, okay, this 15. Then I can say that since the 95 cubes will going to give more than 15, then I'll grade it as M15 grade concrete. So suppose if out of 100 cubes, if 50% of the cube or 50 numbers, 50 cubes will going to give less than this 15, then I cannot say it is M15 grade concrete. No, right? So 95% of the or 95 cubes will going to give more than what is required strength. Then I can say that that is the characteristic strength of concrete. Now see, grade of concrete: M15, M20, M25, M30, M35, M40, so on. Still it is good. Higher grades can be used for the various work. Then what is the characteristic strength now? See here, 28 days compressive strength, and it is denoted as FCK, small f, then CK. FCK means here onwards you have to remember it is the characteristic strength of concrete. Okay, characteristic strength of concrete after 28 days of curing. It is for M15 minimum it is 15 Newton per mm square. It should be 15 Newton per mm square. If it gives higher value, yes, it is good. But it should not give, for M15, it should not give less than 15 after 28 days of curing. Okay, so for M15, minimum characteristic compressive strength after 28 days is 15. For M20, it is 20 Newton per mm square. For M25, 25 Newton per mm square. So on. For M40, it is 40 Newton per mm square. These are the minimum requirement. Higher than this, yes, it is very good grade of concrete, but lower than this, it will not be accepted. Okay, so this is the characteristic strength of what is the characteristic strength of M15 grade concrete? The characteristic strength of M15 grade concrete is 15 Newton per mm square. How you have got this 15? Right? So when you check 100 cubes, right, 95 cubes will going to give this value. Only 5 will give less than this. So maximum will going to give this. So then that will be considered as characteristic strength of M15 grade concrete. Okay. So this is characteristic strength of concrete. Similarly, another material we will going to use. What is that? That is steel. Similarly, what is characteristic strength of steel. In case of steel, the characteristic strength Fy, now it is for steel, characteristic strength is indicated as Fy, that is yield strength, also it is indicated as yield strength Fy. For concrete it is Fck. So in case of steel, the characteristic strength Fy is taken equal to 0.2% of proof stress. So there will be proof stress, 0.2% of that will be characteristic strength of steel, that is Fy, or yield stress, that is 0.2% of proof stress or minimum yield stress, that will be considered as the characteristic strength of steel. It is indicated as Fy. Similarly, now see here, grade of steel. Now suppose if you want to steel in the RCC work or beam, if you want to put the steel in column, beams, footings, slabs, lintels, etc. Which grade? The different grades of steel available. Just like different grades of concrete, right? Different grades of steel available in the market. Now see, Fe 250, Fe 415, Fe 500. For steel, it will come Fe. Okay, Fe will come. So different grades are Fe 250 grade steel, Fe 415 grade steel, and Fe 500 grade steel. So these are the different grades of steel available. For Fe 250 means it is a plain bar. Okay, remember it is a plain bar. Normally we will going to use for the small work. Then Fe 415 and Fe 500 will be the higher grades of steel, higher strength of steel bars that will be used. Now what is the characteristic strength of this Fe 250? So characteristic strength, now it is Fy, right? Again it is Newton per mm square. So for Fe 250 it is 250 Newton per mm square. For Fe 415 it is 415 Newton per mm square, and Fe 500 it is 500 Newton per mm square. So characteristic strength of concrete, then characteristic strength of steel. For concrete it is Fck, and for steel it is Fy. Okay, so remember these are the characteristic strength of materials. Okay, these are the different grades of concrete, and these are the different grades of steel will going to be used in the design. Okay, then similarly these two are characteristic strength of materials. Now similarly there will be characteristic loads. Now as you know, the different loads will be acting on the structure. Okay, so one is a dead load, okay, or self weight of the elements. Then live load will be there. Okay, wind loads will be there, and then in some places we need to consider the earthquake loads also. So various loads will going to considered in the design of elements. So similarly we should know what is the characteristic loads. Now what do you mean by this characteristic load? Characteristic load means the value of the load which has 95% probability of not being exceeded during the life of the structure. Okay, so here see important. What is characteristic load? Characteristic load means it is the load, right, which has probability of 95% probability of not exceeding during the life of the structure. So suppose if you consider normally in the design we're going to consider life of the structure is around 120 years, 150 years, means for 150 years we're going to design the structure. So during this 150 years of span, right, so 95% chances are there the load will not going to be increased. 95% chances are there the load will not going to be increased. So such load is considered as characteristic load. Okay, only 5% there may be chances of increasing the load, but 95% chances are there the load will not going to increase during the lifespan of the structure. So that load is considered as characteristic load. Okay, so characteristic load means the value of the load which has a 95% probability of not being exceeded during the life of the structure. So 95% chances are there the load will not going to be increased. So such load is considered as characteristic load. Then what is characteristic dead load? Dead load means it is self weight of the structure, okay, or self weight of the elements. So characteristic dead load is the weight of the structure itself. Okay, so similarly, characteristic live load and wind loads are taken as per IS 875. What is this IS 875? So again, this is the code we're going to refer as IS 875. So this IS 875 is the I indicates Indian standard. Yes, Indian standard 875. This 875 number indicates code number. So if you refer IS 875, we'll going to get the various loads, live loads and wind loads. How much you're going to take live load and wind load, that we're going to get from this IS 875 code book. Okay. So this is regarding, okay, what? Characteristic load. So important here is characteristic strength of material, characteristic strength of materials, that is characteristic strength of concrete, characteristic strength of steel. Now characteristic load. Okay, next important thing is partial safety factors. So remember here I have mentioned it is important. Partial safety factors, as the name indicates, some factors will going to be used. Okay, some factors will going to be used in the design of structure. Those factors are associated with materials and with loads. So these factors are called as safety factors. Okay, for the safety of the structure or elements, some factors will be used in associated with strength as well as for loads. So those factors are called as partial safety factors. Now see here, these are the factors which are applied to the loads and materials. So just now you have seen materials. Okay, so with these materials and loads, we're going to use these factors to get the design values. So whatever the mentioned here, see here, whatever the mentioned here, these are the characteristic values. This is characteristic strength of concrete, characteristic strength of steel. This is characteristic load. So now here, so these characteristic values will be associated with these partial safety factors. Okay, these are the factors which are applied to the loads and material to get the design value. So our important thing is to get the design values, that is design strength of materials and design loads. So characteristic load we know, characteristic load and characteristic strength of materials we know, but we want to get design strength of materials and design load. Okay, so to get this we're going to be use these partial safety factors. The partial safety factor gamma FC, indication of partial safety factor is gamma F, for limit state of collapse and limit state of serviceability are given in the table. Now see, so when if you want to get these design values, okay, so you have to use this safety factors. So for materials like concrete and steel, see, for materials, the design strength of material FD, okay, design strength, characteristic strength. See here, characteristic strength of concrete is what? FCK. Characteristic strength of steel is FY. Okay, so I don't want these characteristic strength. I want design strength. Okay, design value or design strength. The design strength of material FD is given by. So FD is equal to F divided by gamma M. Okay, remember this. So to get the design values, we have to divide this partial safety factor with this characteristic strength. What is this F? F is the characteristic strength of material. So F, or you can say that FCK. Okay, whatever you have written here, FCK. This is the characteristic strength of concrete and Fy is the characteristic strength of steel. Now here design strength of concrete. Suppose I want design strength of concrete. So design strength of concrete FD is equal to characteristic strength of concrete FCK divided by gamma M. Okay, okay. F is characteristic strength. You can write FCK or Fy. For concrete it is FCK and for steel it is Fy. So this divided by gamma M. Gamma M is nothing but partial safety factor. Okay, so where F is the characteristic strength of material and gamma M is the partial safety factor appropriate to the material and limit state being considered. So depending upon the which limit state we are considering, gamma M value should be put. Okay. Now see, while assessing the strength of a structural member for the limit state of collapse, the value of partial safety factor gamma M should be taken as, now remember, 1.5 for concrete and 1.15 for steel. Okay. So for concrete, what is the partial safety factor? 1.5. That is gamma M value for concrete it is 1.5 and gamma M value for steel it is 1.5. Suppose I want design strength of this M15. Okay, design strength. This is a characteristic strength. This is the characteristic strength. I want design strength of M15 grade concrete. So what I am going to do? Characteristic strength, that is FCK is that is 15. FCK is 15 divided by gamma M. What is the partial safety factor for concrete? It is 1.5. That is 15 divided by 1.5 will give design strength of concrete, M15 concrete, not characteristic strength. This is characteristic strength divided by gamma M, that is 1.5. That will be the design strength. That will be considered for the design. Similarly, if I want design strength of steel, that is Fe415 I want. This is characteristic strength. So characteristic strength is 415. So characteristic strength, that is Fy 415 divided by gamma M. Gamma M is 1.15 for steel. So 415 divided by 1.15 will give the design strength of steel. Okay. So remember, for materials, that is for concrete and for steel, if you want to calculate the design strength, then characteristic strength of material divided by partial safety factor. For materials you have to divide. Okay. So this is partial safety factor to get the design strength of materials. Now similarly loads. So this is the characteristic load. I want to design load now. This load I am not going to consider for the design, because suppose what we are going to do, we are going to design the structure for 150 years. So 150 years, considering the lifespan of the structure, we are going to design that particular structure. So in the initial stages, the load will not going to be increased, but at the later stages we may not say that, we may not consider that load will remain same. It may increase, the load may increase due to some reason. So that load has to be considered in the design. So what we are going to do, we are not going to consider the characteristic load. We want to calculate design load. So the design load FD, D indicates design. So design load FD is given by, so FD is equal to F into gamma F. So here it is same, F and this F will be remain same. Only difference is, for materials we are dividing the partial safety factor. For load we are multiplying the partial safety factor. Okay. So this is gamma M, this is gamma F. Okay. But both are partial safety factors. For loads we are multiplying. So characteristic load multiplying partial safety factor. So where F is the characteristic load, this is the characteristic load what we are considering, this multiplied by gamma F, just like here gamma M, here it is gamma F. Only difference is here we are dividing, for materials we are dividing, for loads we are multiplying. So F is characteristic load, gamma F is the partial safety factor for load. So values of partial safety factor gamma F for load is shown below. Now see, so this is the table we have to remember for partial safety factor for loads, not for materials. So load combination. So there are different load combinations, that is dead load plus live load. Okay, dead load plus wind load, then dead load plus live load plus wind load, all the three loads. Here only dead load and live load. The second load combination, dead load plus wind load. Then third is dead load plus live load plus wind load. So normally we're going to consider this combination, but in majority of the cases, okay, so for high rise buildings this wind load will be considered. Otherwise this is the combination. Then what is the partial safety factor? That is this value, gamma f, what you are multiplying gamma f. So these are the gamma f values. Okay, so for dead load and live load combination, that is two limit state, that is limit state of collapse and limit state of serviceability. So if this is the load combination, then gamma f partial safety factor for dead load it is 1.5, and for live load it is 1.5. For wind load, here wind load is not there, so it will be dash. So similarly for limit state of serviceability, dead load is 1 for this gamma f, dead load is 1 and live load is 1. So similarly these are the values we are going to be considered. These values are nothing but these gamma f values. Okay, gamma f values. So remember, important, what we mean by partial safety factors and how the design strength of material and design loads will be calculated. For design strength of materials, that is for concrete and steel, we are dividing the partial safety factor, that is considering characteristic strength of material divided by partial safety factor, we are going to get the design strength of the material. But for design loads, we are multiplying the partial safety factor. Characteristic load multiplied by the partial safety factor. So important thing, remember what you mean by characteristic strength of material, that is characteristic strength of concrete and characteristic strength of steel. These two are characteristic strength of materials. Then what is characteristic load, you have to remember. Then how the partial safety factors are considered to calculate the design values, and these are the partial safety factors for the loads, okay. So this is what the today's session. Okay, understand the important of these two criteria, that is characteristic strength and design strength. Okay, so if you have any doubt, feel free to ask. Okay, and in the next session we'll come up with another interesting topic. Okay, thank you very much for attending this session. Thank you.